Hello students, hope you are all doing good. Yes, in this session we are starting chapter aldehydes, ketones and carboxylic acids. Aldehydes, ketones, and carboxylic acid. See, here we are studying properties and reactions, preparations of aldehydes and ketones together. Later let's study about carboxylic acid. Okay, so which is the functional group present in aldehyde, ketone and carboxylic acid? That is C double bond O. This is the main functional group which is present in aldehydes and ketone. This group is called as carbonyl group. Carbonyl functional group. C double bond O group. This group is called as carbonyl functional group. Carbonyl functional group. This is the main functional group which is present in aldehydes and ketones. See, if I replace or if I place one R alkyl group, R represent alkyl group, and one hydrogen, I'll get aldehyde. Or if I replace this hydrogen by any other alkyl group, I'll get ketone. Okay, so both aldehydes and ketones contain same functional group. Okay, so here for aldehydes, for IUPAC nomenclature, suffix AL is used, and for ketones suffix ONE is used. Okay, next is preparation of aldehydes and ketone. First let us study some of the common methods of preparation of aldehydes and ketones. First we are studying 3 to 4 common methods of preparation for both aldehydes and ketones, and later on let us study one by one. That's for preparation for only aldehydes and preparation for only ketones. First method is by oxidation of alcohol. See, alcohols, if you take primary alcohol on partial oxidation, remember I am doing partial oxidation here. Partial oxidation will give aldehyde. Here we are supposed to have some of the reagents. I'll tell those reagents. And secondary alcohol on partial oxidation will give ketone. Okay, let me take an example for primary alcohol, that is CH3, CH2, OH, ethanol. This is an example for primary alcohol. If I oxidize this in the presence of PCC or PDC, pyridinium chlorochromate or pyridinium dichromate, I'll get aldehyde, that is CH3, CHO. So primary alcohols on oxidation, that is partial oxidation, will give aldehyde. I'll consider one secondary alcohol, CH3, CH3, OH, propan-2-ol. So this on oxidation, same reagents, PCC, PDC, or that's partial oxidation in the presence of PCC or PDC will give CH3, CH3 double bond O. Okay, this is the reaction here. Primary alcohols on partial oxidation will give aldehyde. Secondary alcohols on partial oxidation will give ketones. Remember this reagents. Okay, next second method of preparation is by dehydrogenation of alcohol. By dehydrogenation of alcohol. This is second method of preparation of aldehydes and ketones. Here primary alcohols, if I treat primary alcohols, let me take ethanol only, CH3, CH2, OH. This primary alcohol, on treating it with copper in at 570 573 Kelvin temperature. Reaction of primary alcohols in the presence of copper at 573 Kelvin temperature will give aldehyde CH3CHO. Ethanol. I took ethanol, that is alcohol, this is primary alcohol, and I got ethanol. So see, suffix al is used for aldehydes. If I take secondary alcohol, R, CH, R dash. I took general example of this. This is general example for secondary alcohol. This on treating with copper at 573 Kelvin temperature, I will get C double bond O R dash, that is ketone. In both these two cases, that is in previous example and in this case, only the reagent is different. There I took PCC or PDC, here I am taking copper at 573 Kelvin temperature. Primary alcohols will give aldehydes, secondary alcohols will give ketone. Okay, yeah. Next is by hydration of alkynes. Third method is by hydration of alkynes. This is third method. Okay, third method of preparation of aldehydes and ketones. Now I will take example of alkyne, that is ethyne, CH triple bond CH. Ethyne, hydration means adding water, so H2O, I will take it as H and OH in the presence of H plus. See what will happen, electrons will move towards one carbon atom, so this carbon atom will get partial negative charge and other will get partial positive charge. Positive charge will be created, not partial, completely positive charge. So what will happen, this H2O will dissociate into H plus and OH minus. So this H plus will attach to this carbon containing negative charge and this will attach to carbon containing positive charge. So what I will get is CH, here I will get CH2 double bond CH OH. Here what I got is alcohol, but I have to prepare aldehyde. So what this will undergo tautomerism. Tautomerism means, let me tell you, tautomerism. See in this example, oxygen will take this electron and there exists a lone pair of electron on oxygen that will shift to this bond and double bond formation will take place here, and so here this electrons will shift on this carbon atom. So I will write over here CH as it is, double bond O, this bond will break and you will get H plus. This H plus will attack on this carbon atom, CH2 minus is there, so H plus will attack on this carbon atom, or this carbon atom attacks H plus and it forms CH3CHO. This is aldehyde. Tautomerism will take place. In the same way you can even prepare ketone also, like same method. I will take CH3C triple bond CH, so that is propyne. If I hydrolyze this HOH, what will happen, electrons will move here creating positive charge on this carbon atom because secondary carbocation is more stable than primary carbocation. Okay, so positive charge will be created on this carbon atom and this receives negative charge. So what will happen, hydrogen will attack on this carbon atom and OH will attack on this carbon atom, OH minus, in the presence of H plus. Okay, I will get CH3 COH CH, sorry, double bond CH2. This will undergo tautomerism to form CH3 C double bond O CH3. That means, so OH bond, electrons in OH bond will shift here and it will shift here. It will extract proton from this hydrogen, or it will extract this proton. Okay, so here you will get ketone. Except ethyne, every other alkyne will produce your ketone. Only ethyne will produce aldehyde. Remember this. Okay, yeah, these are three methods of preparation of aldehyde as well as ketone. Next is preparation of only aldehyde. Preparation of aldehyde. Okay, first method of preparation is from acyl chloride. So this is important, very important method of preparation of aldehyde. This method is called as Rosenmund reduction. That is, preparation of aldehydes from acyl chloride is called as Rosenmund reduction. Here I will take acyl chloride, R C double bond O Cl. This C double bond O Cl, this group is called as acyl group. I took acyl chloride. So when you treat this acyl chloride with H2 in the presence of palladium supported over barium sulfate, BaSO4, will give R C double bond O H. What will happen? One hydrogen will attach to this carbon and another hydrogen will take this Cl. Okay, it will form HCl. This is the actual method of preparation of aldehyde. This method is called as Rosenmund reduction. You can even take aromatic aldehyde also. See, if I take benzoyl chloride, C double bond O Cl, this is benzoyl chloride. This benzoyl chloride on treatment with hydrogen in the presence of palladium supported over barium sulfate catalyst will form benzaldehyde, CHO plus HCl. This is called as Rosenmund reduction. Remember this. This is one of the very important method. In Rosenmund reduction, what you will do? You will take acyl chloride. Acyl chloride on treatment with hydrogen in the presence of palladium supported over barium sulfate catalyst will produce aldehyde. Okay. So next is, second method is from nitriles. This reaction is called as Stephen's reaction. Stephen reaction. Okay, from nitriles, preparation of aldehydes from nitriles is called as Stephen reaction. So here what we will do is, you will take nitrile. Now general formula for nitrile is RC triple bond N. This on treatment with hydrogen in the presence of SnCl2, stannous chloride. Nitriles on treatment with hydrogen in the presence of SnCl2 will form intermediate, that is imine, RCH double bond NH. See, two hydrogen atoms are there in hydrogen molecule, hydrogen. What will happen? These two bonds will break. So this will attack here and this will attach here. This bond will also break. Okay, one bond between carbon and nitrogen will break. So you will get RCH double bond NH. One hydrogen will attach to carbon, another hydrogen will attach to nitrogen. This is imine. Imine intermediate will be produced. On hydrolysis, this imine on hydrolysis. Hydrolysis means addition of water. So what will happen if I add water to imine? See, I will write it like this: oxygen, H2O, H. This bond will break. So NH3 will be produced and carbon will attach to oxygen through double bond. So what should I get? R, C, double bond O, H plus NH3. So here I got aldehyde. This is another method of preparation of aldehydes, that from nitriles. This reaction is called as Stephen reaction. You can take any nitrile. Okay, here I took general example. For any nitriles you can perform this reaction. Next, third reaction is Aldehydes reaction. Third reaction is Itard's reaction. Itard's reaction. So one of the important reagent in Itard's reaction is chromyl chloride, CrO2Cl2. This is chromyl chloride, which is the important reagent in Itard's reaction. So in Itard's reaction, partial oxidation of your toluene will take place. This is toluene, CH3. Complete oxidation of toluene. Complete oxidation of toluene will give acid, but I don't want acid here, I want aldehyde. So partial oxidation of toluene in the presence of CrO2, Cl2 and CS2, carbon disulfide, followed by hydrolysis, H2O will give benzaldehyde. This reaction is called as Itard's reaction. Partial oxidation of toluene in the presence of chromyl chloride and carbon disulfide, followed by hydrolysis will give benzaldehyde. This reaction is Itard's reaction. Okay. Next, fourth reaction is Gutterman-Koch reaction. Gutterman-Koch reaction. Fourth method of preparation is Gutterman-Koch reaction. Here you will take benzene on reaction with carbon monoxide in the presence of HCl. Benzene reacts with carbon monoxide in the presence of HCl and anhydrous AlCl3. Okay, this anhydrous AlCl3 acts as a Lewis acid. Benzene on treatment with carbon monoxide and HCl in the presence of anhydrous AlCl3 will give benzaldehyde, CHO. This is an example for, or this is Gutterman-Koch reaction. So here in Gutterman-Koch reaction you are converting benzene to benzaldehyde by treating it with carbon monoxide and HCl in the presence of anhydrous AlCl3. So these are four methods of preparation of only aldehydes. You cannot prepare ketones by using this method. Next is preparation of ketone. Preparation of ketone. Preparation of ketone. First method of preparation of ketone is from azyl chloride. From azyl chloride. See, here you will treat azyl chloride, Rc double bond OCl, with cadmium chloride. Sorry, dialkyl cadmium, R2CD. This is dialkyl cadmium. So this azyl chloride on treatment with dialkyl cadmium will give Rc double bond O R plus CD Cl2. So you need to balance this reaction. Everywhere I am not going to write balanced reaction. You should be able to balance all the reactions. Okay. See, I took azyl chloride on reaction with dialkyl cadmium will give ketone. I got ketone here. So how will you prepare this dialkyl cadmium? By reaction with Grignard reagent. I will take Grignard reaction of Grignard reagent RMgX. This is Grignard reagent. This on reaction with cadmium chloride will give dialkyl cadmium. I want two alkyl groups, so I will write it like this and I will get 2 Mgx Cl. Okay, this is how you will prepare dialkyl cadmium. This dialkyl cadmium on reaction with azyl chloride will give you ketone. This is one method, and next method is, second method of preparation is from nitriles. From nitriles. So general example for nitrile is RC triple bond N. This nitriles on reaction with RMgX, that is Grignard reagent, in the presence of ether. Nitriles react with Grignard reagent in the presence of ether. Here R will receive positive charge and MgX will receive, R will receive negative charge and MgX will receive positive charge. So what will happen? This will attack on this carbon atom and it will move over here. This negative charge extract this one. So I will get R, C, R, double bond, N, Mg, X. This on further hydrolysis, this intermediate on hydrolysis, that means by treating it with H2O. How it will break? Oxygen, hydrogen, hydrogen, like this. It will break like this. I will get R, C, double bond O, R, that is ketone. This is another method of preparation of ketone. Okay, second method. And next method is Friedel-Crafts acylation. Friedel-Crafts acylation reaction. Benzene on treatment with CH3, C double bond O, Cl, that is acyl chloride in the presence of anhydrous Al, Cl3 will give aromatic ketone, C double bond O, CH3. This is another method for preparation of ketone from Friedel-Crafts acylation reaction. So these are some methods of preparation of aldehydes and ketones. Next is chemical reactions of aldehydes and ketones. Chemical reactions of aldehydes and ketones. See what will happen. First chemical reaction, first let us study nucleophilic substitution reaction. Nucleophilic substitution reaction. So this is aldehyde or ketone, C double bond O, and I will attach a group A and one more group, that is B. So every atom in aldehyde or ketone will be in a single plane. This is a planar molecule, but due to electronegativity difference between carbon and oxygen, oxygen will receive partial negative charge and carbon will receive partial positive charge. So this carbon acts as a nucleophilic center. Nucleophile will attack on carbon atom, Nu minus. I will represent nucleophile as Nu minus. This will attack on carbon atom. So this is a very slow step and I will get carbon in a plane. Let carbon, nucleophile will attack from upper or lower side, O minus, and one nucleophile attack on this carbon atom, this will move on oxygen, bond electrons in this bond will move on oxygen. So and A, B, A and B can be in, it may be aldehyde or ketone, so I took A and B as general example. Okay. Now this on acidification, this is a tetrahedral intermediate. This was planar and I got a tetrahedral intermediate. Planarity will be removed, and this on acidification, on treatment with H plus, what will happen? H plus will attack on this O minus. O minus will abstract H plus ion. So I will get C Nu, that is nucleophile, and one atom A and B OH. Okay, this is what happens. Always remember this, aldehydes are more reactive than ketones. Aldehydes are more reactive than ketones. This is because, see, for aldehyde, for towards nucleophilic substitution reaction, remember this, because see, this is aldehyde H CH3 and this is ketone CH3 C double bond O CH3. So what nucleophile want? Nucleophile want positive charge. Here positive charge will be created on this carbon atom. But due to your plus I effect, this carbon will donate electrons and it neutralizes some positive charge on this carbon atom. Actually, if the amount of positive charge is greater, nucleophile can easily attack on this carbon atom. Here, because of plus I effect, electron donating effect, this CH3 is neutralizing some positive charges. But in case of ketone, there are two CH3 groups, so partial positive charge will be still less on this carbon atom, because both these groups are donating electron. That means they are stabilizing this carbon atom. So what will happen, due to this stabilization of this carbon atom, this will become less reactive. But here it contains only one electron donating group, so it can react easily. So this is C double bond O H, formaldehyde. Formaldehyde is highly reactive than other aldehydes, which are more reactive than ketones, because there is no electron donating group in case of formaldehyde. Both are hydrogen and hydrogen. But in case of any other aldehydes, electron donating group will be present. But in case of ketone, on both the sides electron donating group will be present. This stabilizes this carbon atom, okay, by donating their electrons. So now let us study some of the nucleophilic substitution reaction. First one is addition of HCN. These are all very simple reactions. Addition of HCN. So aldehydes and ketones will undergo same type of reaction. First let me take one aldehyde, CH3, C double bond O H. Here what you should know is which is nucleophile. Since this is nucleophilic substitution reaction, you should know which among this is nucleophile. So on adding HCN, here it will split as H plus and Cn minus. Cn minus is nucleophile which attacks on carbon atom, and electrons in this move on oxygen, and oxygen takes this proton. So I will get CH3, C, H, Cn, O, H. This is cyanohydrin. In the same way, ketones also react with HCN. CH3, C double bond O, CH3 on treatment with HCN. H plus and Cn minus. H plus and Cn minus. Cn minus will attack on this carbon atom. So electrons will move and they will take, so that electrons will take this H plus. So I will get CH3, C, OH, CH3, Cn. That is cyanohydrin. So if aldehydes or ketones on reaction with hydrogen cyanide will give cyanohydrin. Very easy reaction. You should know which one is nucleophile. That's all. And next is reaction with sodium bisulfite. Sodium NaHSO3. Sodium bisulfite. Reaction of aldehydes or ketones with sodium bisulfite. So here this is structure of sodium bisulfite. NaO S double bond O OH. This is sodium bisulfite structure. It dissociates as Na plus and HSO3 minus. Aldehydes or ketones, I will take example of only aldehyde, you can write it for ketone also, C double bond OH. Aldehydes or ketones on reaction with NaHSO3, that is sodium bisulfite, will give CH3, C, O, Na, H as it is, and nucleophile, that is OSO2 H. Here what will happen, this sodium will come and attach here, this hydrogen will be abstracted by this oxygen. So I will get CH3, C, OH, H, O, SO2 Na. So this is a bisulfite addition compound. You will get a bisulfite addition compound after this reaction. So this is how aldehydes or ketones react with sodium bisulfite. Here I took only example of aldehyde. You can even write it for ketones also. Next is addition of alcohol. Addition of alcohol. So aldehydes or ketones on when they react with alcohol to give hemiacetals and acetals. See, I'll write the reaction R C double bond O H. This is general example for aldehyde. I'll treat it with alcohol or OH. It dissociates as R plus and OH minus. Sorry, it dissociates as RO minus and H plus. RO minus and H plus. Alcohol dissociates like this. Okay. So what will happen? This RO minus will attack on carbon atom. So what I'll get? R C H as it is, OR, which is a nucleophile. This will attack on this carbon. Electrons will move here, and that which abstract a proton. So I'll get OH. This is hemiacetal. Hemiacetal structure. This hemiacetal reacts with one more ROH, one more ROH, one more alcohol in the presence of H plus. This is a reversible reaction. Okay, ROH in the presence of H plus. Here removal of water molecule will take place. This like this. This will be removed. Water molecule will be removed and RO will attack to this carbon atom. So I'll get R C H O R and OR plus water. H2O will be removed. So this is acetal. So aldehydes or ketones react with alcohol to form hemiacetals and acetals. Okay. So if I treat ketones or aldehydes, any aldehydes or ketones with ethylene glycol, C double bond O, treated with ethylene glycol. The structure of ethylene glycol is like this: CH2, CH2, OH, OH. Here removal of water molecule in the presence of HCl gas, HCl gas and dilute HCl. What will happen? Removal of water molecule will take place like this. It will form a cyclic compound R O CH2 CH2 O like this. Okay. So this is a compound plus water plus H2O. This is how aldehydes or ketones react with alcohol. They will form hemiacetals and acetals. Okay. Next is addition of NH3 and its derivatives, that is addition of ammonia and its derivative. Addition of that is reaction of aldehydes or ketones with ammonia, NH3 and its derivatives. So what will happen on reaction of aldehydes and ketones with ammonia and its derivative? Let me take general example. This is NH3. If I remove one hydrogen and replace it by any other group like Z, this is general example for any other group. You can replace it by any other group, you will get derivative of ammonia. Okay. So I'll take aldehyde or ketone which contains carbonyl group, and if I treat it with ammonia or its derivative, okay, this Z can, if Z is H, it will become ammonia. If Z is any other group, it will become derivative of ammonia. Okay. Yeah, what I'll get, removal of water molecule takes place from here. Water molecule will be removed. So C double bond N Z, water molecule will be removed. So this is the final product. So this is general reaction. Remember only this reaction, that is more than enough. You can write any reaction, that is reaction of aldehydes or ketone with ammonia and its derivative. For example, If Z is equal to H, then that is called as ammonia. Ammonia. If I replace this Z by H, I will get ammonia. Ammonia on reaction with aldehydes or ketones, it will form C double bond NH. See, this instead of Z I took H. So this is Z, I took H instead of Z, I will get NH. So the name of this compound is imine. Now I will take Z as alkyl group R. So this is amine, then it will become amine, like RNH2, it will become RNH2, that is amine. Amines will form a compound like this. Nothing, only replace this Z by the group which you have taken, R. This is called as, this is a Schiff base. This is Schiff's base. Okay. Next is, if I replace Z by OH, so I will get hydroxylamine. Hydroxylamine. So in product, what I have to do is, I have to replace Z by OH, NOH. This is oxime. The name of this compound is oxime. Okay. This way it continues. You can take Z as NH2, that is hydrazine, or you can take 2,4-DNP, anything, you can take anything for Z. Okay. Yeah. Next one is 2,4-DNP test for aldehydes or ketones. Aldehydes, remember this is one of the very important test for detection of aldehydes and ketones. So aldehydes and ketones will react, with 2,4-DNP dinitrophenylhydrazine to give orange or yellow PPT. Orange or yellow PPT. So this is one of the very important method for detection of aldehydes and ketones. Any aldehydes and ketones reacts with 2,4-DNP. If you take an organic compound containing aldehyde or ketone, and if you treat it with 2,4-DNP, you will get orange or yellow precipitate. So this is about nucleophilic substitution reaction. Next is reduction reaction. Reduction reaction. Reduction reaction. See, I will take aldehyde CH3CHO and I will reduce it with the help of lithium aluminium hydride LiAlH4 or sodium borohydride NaBH4. So these are reducing agents. So aldehydes will reduce to corresponding alcohol CH2OH. I took ethanol and I got ethanol. While learning preparation of aldehyde, we have converted ethanol to ethanol by oxidation reaction. Oxidation of ethanol will give ethanol. Reduction of ethanol, that is aldehyde, will give alcohol. Okay, this is a reverse reaction. Aldehydes on reduction will give primary alcohol. Aldehydes on reduction will give primary alcohol. If I take a ketone CH3 C double bond O CH3 on reduction with same reagent lithium aluminium hydride or sodium borohydride NaBH4, lithium aluminium hydride or sodium borohydride will form CH3COH CH3, that is secondary alcohol. So what it indicates? Aldehydes on reduction form primary alcohol, ketones on reduction form secondary alcohol. So this is reduction reaction, how the reduction reaction takes place with lithium aluminium hydride or sodium borohydride. Next reaction is Clemmensen reduction. Clemmensen reduction. So in Clemmensen reduction, if you take any aldehyde, double bond O, and if you treat it with zinc amalgam, ZnHg, aldehydes or ketones react with zinc amalgam in the presence of HCl to form CH2H. This is alkane. Alkane will be formed. Aldehydes are converted into alkane, corresponding hydrocarbons. You can say corresponding hydrocarbons. Preparation of hydrocarbons by treating aldehydes or ketones with zinc amalgam in the presence of HCl is called as Rosenmund reduction. Nothing, just replace this by H2. That's all. This is Clemmensen reduction. Next is Wolff-Kishner's reduction. Wolff-Kishner reduction. Wolff-Kishner reduction. So here also you will take aldehyde or ketone. Aldehydes or ketones react with NH2 hydrazine. Okay, so here what will happen, you have already learned this reaction. So removal of water molecule will take place, H2O, and nitrogen will take the place of oxygen. So I will get C double bond N NH2. So this is hydrazone. This compound, name of this compound is hydrazone. This hydrazone on treatment with KOH or ethylene glycol, on heating, this hydrazone with KOH or ethylene glycol will give CH2 plus N2. This is a reaction. Okay, directly you can write like this also. You can skip this intermediate step. Aldehydes or ketones on reaction with NH2 hydrazine will form alkanes, corresponding alkanes or corresponding hydrocarbons. Okay, so this is Wolff-Kishner's reduction, Clemmensen reduction and Wolff-Kishner's reduction. These two are very important reactions. Next is oxidation reaction. Next reaction of aldehydes and ketone is oxidation reaction. Aldehydes on complete oxidation, aldehydes on oxidation in the presence of alkaline KMnO4 and Jones reagent will give acid. Acid formation will take place on oxidation of aldehydes. If I take CH3CHO, so what is Jones reagent? That is CrO3 in the presence of aqueous H2SO4 and acetone. This is Jones reagent. Okay, so I will take aldehyde ethanol. This on oxidation, same reagent, you can use same reagent, you will get CH3COOH, that is acid, acetic acid will be obtained. So aldehydes on oxidation will give acids. So in oxidation of ketone is bit difficult. Oxidation of ketones takes place only under certain vigorous condition. This is oxidation reaction. Next is aldol condensation reaction. Next important reaction is aldol condensation reaction. Aldol condensation reaction. So here you should remember one important point. Carbonyl compounds containing alpha hydrogen. Carbonyl compounds containing alpha hydrogen in alkaline medium, in dilute alkali medium. only in carbonyl compounds containing alpha hydrogen in dilute alkaline medium will undergo aldol condensation. This is very important. Aldol condensation is given by carbonyl compounds containing alpha hydrogen atom. They should contain alpha hydrogen. What is alpha hydrogen? I will take one aldehyde. So here the carbon very next to this carbonyl functional group is called as alpha carbon atom. So the hydrogen on alpha carbon atom is called as alpha hydrogen atom. So when you treat, so this is alpha hydrogen atom, but this is not alpha hydrogen, it is directly attached to carbonyl carbon. The carbon next to carbonyl carbon is called as alpha carbon atom. The hydrogen attached to alpha carbon atom is alpha hydrogen. Okay. So when you treat this with dilute alkali, I will take dilute NaOH, you will get CH3 C. So here 2 molecules of your carbonyl compound will react containing alpha hydrogen. So total I will get 4 carbon atoms, 2 from each aldehyde. So 4 carbon atoms will be there. So in 4 carbon atoms, one group will remain as it is, CHO. I will write this at the end. Next, its next carbon, C. Okay. So and another carbon which contains functional group, it will form OH. I will tell you simple way to write this. Just now remember the product, CH2 and C. Yeah, here it comes CH. Oh shit, wait, yeah, CH3, CH, OH, CHOH, CH2, CHO. This is a reaction. It forms beta hydroxy alcohol will be formed. Both aldehydes and ketones containing alpha hydrogen atom will give this type of product. This is I know it's a bit difficult to remember. I will tell you easy method. First just remember this. This on heating will undergo dehydration reaction, removal of water. So this is beta carbon atom. This is alpha, this is beta, because carbonyl functional group is here, C double bond O group, alpha beta. Beta hydroxy alcohol will be formed. This beta hydroxy alcohol on heating, what will happen? OH group will be removed from beta carbon and hydrogen will be removed from alpha carbon atom. So I will get CH3, CH, double bond, CH, CHO. This is the reaction. I will get unsaturated compound. So simply you can write this reaction like this. First I am taking 2 aldehydes containing alpha hydrogen, right? So I will take one compound containing alpha hydrogen, C double bond OH. It has 3 hydrogen atoms like this. This is what I have written last time, CH3 CHO. Okay, so complete structure. Now this will react with one more compound containing alpha hydrogen like this, CH3. So here removal of water molecule will take place. So what I will get in the presence of dilute NaOH. This is aldol condensation only. I am giving you a simple trick to write this. Okay. So removal of water molecule takes place. So I let this CH3 first. This CH3, which is attached to carbon atom. That carbon atom has one hydrogen, CH, and this carbon atom attached to this. Oxygen will be, H2O will be removed. So carbon will form double bond with this carbon atom. That carbon atom also contains one hydrogen and CHO. This carbon atom attaches to CHO. So this will be single step method for writing aldol condensation reaction. You can write this even for ketones also. Okay, in same method. Next is Cannizzarose reaction. Next is Cannizzarose reaction. Cannizzarose reaction. Here carbonyl group should not contain, it should not contain, carbonyl group should not contain alpha hydrogen. Alpha hydrogen atom should not be there on carbonyl group or carbonyl carbon atom. And here disproportionation reaction will take place. That means oxidation and reduction takes place simultaneously. That type of reaction is called as disproportionation reaction. Cannizzarose reaction is an example for disproportionation reaction. Here I'll use concentrated alkali. For example, I'll take HCHO, formaldehyde, C double bond O, H, this is HCHO. There is no alpha carbon atom, there is no alpha carbon atom, no alpha hydrogen. Okay. Now this two molecules of this react with concentrated alkali, concentrated NaOH, or you can even take KOH also. So one will be oxidized. There are two molecules, one will be oxidized. Oxidation of this aldehyde will give HCOO Na, that is acid of salt. Okay, sorry, yeah, contains a salt, sodium salt of carboxylic acid, and next is, and this is oxidized product, and another one will be reduced product. Reduction of aldehydes will give, reduction will give alcohol, CH3OH. One will be oxidized product, another one will be reduced product. You will get two different products in Cannizzarose reaction. Carbonyl compound which do not contain alpha hydrogen in the presence of concentrated NaOH will undergo disproportionation reaction. One will form sodium salt of carboxylic acid or potassium. If you use KOH, it will form potassium salt of carboxylic acid, and on reduction it will form alcohol. One will be oxidized product and another one will be reduced product. Okay, hope you understood this Cannizzarose reaction. Next is tolerance test with detection for aldehydes and ketones. Tolerance test. See, this is given by aliphatic and aromatic aldehydes. Aliphatic and aromatic aldehydes will give tolerance test. Aliphatic and aromatic, aliphatic and aromatic aldehydes will give tolerance test. Here you will take aldehyde or aromatic or aliphatic aldehyde RCHO react with tolerance reagent. Tolerance reagent is AgNH3 twice plus. This is tolerance reagent in the presence of OH minus. What will happen? This is aldehyde. When you treat it with tolerance reagent, reduction of silver will take place. Here silver is in +1 oxidation state. This will form RCOO minus. So here silver is undergoing reduction and aldehyde is undergoing oxidation. Aldehyde on oxidation will give acid, okay, plus Ag. Silver will be reduced to metallic silver plus NH3 plus H2O will be formed. Balance this reaction. This is not completely balanced, okay. So this you can balance it like this. 3OH, then it will form 2 plus 4 NH3 plus 2H2O. Okay, now it is balanced. See, due to the formation of metallic silver, silvery appearance will be there in the solution, which indicates the presence of aliphatic or aromatic aldehydes. Remember this, aliphatic or aromatic aldehydes on tolerance reagent will form silver mirrors. Silver mirrors will be formed inside the test tube or inside the vessel which you are taking. Usually it will be done in test tube. So this is one of the very important method. Here aldehydes will be oxidized and reduction of silver to metallic silver will takes place. This is test for tolerance test for detection of aliphatic and aromatic aldehydes. Next is Felling's test. Felling's test. So this is given by aliphatic aldehydes. This test is given by aliphatic aldehydes. So what they will do is, aliphatic aldehydes are CHO. They will react with Felling's reagent which contains copper plus 2 in the presence of OH minus. This Cu plus 2 is a blue colored solution, that is Felling's reagent is a blue colored solution, and they will form RCOO minus plus Cu2O plus H2O. This Cu2O, that is cuprous oxide. Cuprous oxide is a red colored precipitate. Red colored precipitate formation indicates the presence of aldehydes. Aldehydes on reaction with Felling's reagent will form red precipitate, cuprous oxide. Cuprous oxide will give red precipitate. This is detecting test for aliphatic aldehydes. Next is iodoform test. Iodoform test. So in iodoform test, you will take CH3. I will take one example for only this type of group. Compounds containing this type of CH3 C double bond O group will give iodoform test. That group should be there to give iodoform test. Here what will happen when you treat any aldehyde containing CH3 C double bond O group with I2 in the presence of NaOH will form CHI3. So this CHI3 will give yellow precipitate. This is iodoform test. Okay, so that is about aldehydes and ketones. Next is carboxylic acid. Carboxylic acid. Iodoform test is one of the very important tests for the detection of aldehydes. Okay, that is CH3C double bond O group. Next is carboxylic acid, which is the functional group present in carboxylic acid, C double bond O OH. This is the carboxylic functional group. So this is acidic in nature. First is preparation. Methods of preparation of carboxylic acid. Preparation of carboxylic acid. How can you prepare carboxylic acid? First method of preparation is from primary alcohol and aldehyde. Primary alcohols and aldehydes. See, I take one primary alcohol, CH3 CH2OH, ethanol. This is primary alcohol. If you treat this primary alcohol with alkaline KMNO4 and John's reagent will give CH3COOH, that is carboxylic acid. Complete oxidation of alcohol. Partial oxidation will give aldehyde. Complete oxidation will give carboxylic acid, ethanoic acid. I took ethanol and I got ethanoic acid. So even your aldehyde CH3CHO on oxidation with alkaline KMNO4 and John's reagent will give CH3COOH, that is carboxylic acid. Both primary alcohols and aldehydes on treatment with alcoholic KMNO4 and John's reagent will give as carboxylic acid. Okay, next is second method of preparation. Second method of preparation is from alkyl benzene. Alkyl benzene. So alkyl benzene means toluene. Let me take simple example, toluene, CH3. This on treatment with KMNO4 in the presence, toluene on heating with KMnO4 in the presence of KOH. In the presence of KOH will give intermediate compound, that is potassium salt, potassium benzoate, COOK. Potassium benzoate will be formed. This potassium benzoate on acidic hydrolysis will give benzoic acid, COOH. Benzoic acid will be formed. This is from alkyl benzenes. I took simple example of toluene in this case. Okay. So next, third method is by hydrolysis of amides. By hydrolysis of amides. By hydrolysis of amides. So if I take benzamide, CONH2, this is benzamide. Benzamide on acid hydrolysis, H3O plus, I will consider H3O plus. Benzamide on heating with water, acidic hydrolysis will give benzoic acid, COOH, benzoic acid plus NH3. See what will happen here, addition of water, OH, this bond will break, carbon and nitrogen bond will break and it will form COOH. COOH and NH3 will be formed. Remember it like this. Okay. So this is preparation of acid by amide. Next is from Grignard reagent. Fourth method is from Grignard reagent. From Grignard reagent. Grignard reagent is RMgX. This is Grignard reagent. If you treat it with carbon dioxide, that is dryides, carbon dioxide in dry ether, in the presence of dry ether, Grignard reagent reacts with carbon dioxide in the presence of dry ether to form RC double bond O, OMgX. This on treatment with H3O plus, that is acidic hydrolysis, will give RCOOH. This is fourth method of preparation of acid from Grignard reagent. Next is by hydrolysis of acyl chloride. Fifth method is by hydrolysis. By hydrolysis of acyl chlorides. So acyl, I will take CH3 acetyl chloride, that is CH3COCl. This is acetyl chloride. Hydrolysis H2O. See here, I will get CH3 H2OH. This is H2O. This bond will break. HCl will be removed. CH3COOH plus HCl. Ethanoic. I got ethanoic acid. As I took acetyl chloride, on treatment with water, it will form ethanoic acid. Next is sixth method is from aster. From aster. Here also same process. I will take ethyl acetate, CH3C double bond O, CH2 CH3. Ethyl acetate on reaction with water, H2O, will form CH3 C double bond O OH. C double bond O OH, like this it will happen. H OH, this bond will break. This will attach to this oxygen and it will take away this. I will get CH3 CH2 OH, one acid and one alcohol. So since I am preparing acid, I will get acid from this reaction from aster. Okay, hydrolysis of aster will give alcohol and acid. So these are all some methods of preparation of your acids. Next is chemical reactions of carboxylic acid. Chemical reactions. let's study some of the chemical reaction. First chemical reaction is reaction with metals reaction with metal and alkali. How it will react with metal and alkali? Let's check now. I'll take acid CH3COOH, that is acetic acid. This will react with sodium metal. So what will happen? It will form sodium acetate, CH3COONA plus H2 gas will be liberated. That means metals will liberate hydrogen gas from acids. Remember, this metals will liberate hydrogen gas from acids. This is not balanced reaction, you should balance this, okay. Sodium acetate will be formed and hydrogen gas will be liberated. So in the same way, if you treat your CH3COOH acetic acid with NaOH alkali, NaOH, it will form sodium acetate CH3COONA plus water will be formed, H2O, water molecule formed like this. H2O will be removed and Na will attach to this one to form sodium acetate. Okay, so this is reaction of acid with metal and alkali. Next is reaction with NaHCO3, sodium hydrogen carbonate. So what will happen? Reaction with sodium hydrogen carbonate. You can take, I'll take acetic acid CH3COOH. This will react with sodium hydrogen carbonate to form CH3COONA, CH3COONA and plus H2O plus CO2 will be formed. Liberation of CO2 will take place. Remember this, sodium hydrogen carbonate will liberate carbon dioxide from acids. You can take any acid on reaction with your sodium hydrogen carbonate, that is weak base. This is weak base. Acids, carboxylic acids on reaction with weak base will liberate carbon dioxide gas. Remember this, liberation of carbon dioxide gas will takes place, which forms brisk effervescence. Brisk effervescence will be formed. Okay, so always carboxylic acids are stronger acids than phenols. Carboxylic acid is stronger acid than phenol. Electron withdrawing group. If I attach electron withdrawing group, this is acid. If I attach electron withdrawing group to carboxylic acid, will increase its acidic strength. Okay. Next is formation of anhydrides. Next topic is formation of anhydride. Formation of anhydride. I will take two carboxylic acids, CH3, C double bond O, OH plus C double bond O, CH3, OH, and I will treat it or I will heat it in the presence of acid, or I will heat it with P2O5. Heating this with P2O5, what it will give? Anhydride should be formed. CH3, C double bond O, O, C double bond O, CH3. Removal of water molecule will take place. Anhydride will remove water content from the molecule. Two acids on heating with P2O5 will form, or heating with acid will form anhydride. Anhydride formation will takes place. So this is ethanoic anhydride. Ethanoic anhydride. Next is esterification reaction. Esterification reaction. See, in anhydride formation, I took two acids, two different. You can take same acid or different acid that both will form anhydrides only. Now in esterification reaction, I will take one alcohol and one acid, like I will take CH3 OH methanol. This will react with ethanoic acid. C double bond O, OH, CH3. This will react with ethanoic acid in the presence of acid, any acid catalyst. It will form CH3, O, C double bond O, CH3, that is methyl ethanoate will be formed. Methyl ethanoate will be formed, that is ester formation will take place, plus H2O, water molecule will be removed. This is esterification reaction. If you take 2 carboxylic acids, you will get anhydride. If you take 1 alcohol and 1 acid, you will get ester. Okay, next is reaction CH3 COOH reacts with PCl5. PCl5, acetic acid reacts with PCl5 and it forms CH3COCl plus POCl3 plus HCl, that is acetyl chloride, CH3COCl, acetyl chloride, and phosphorus oxychloride will be formed. This is phosphorus oxychloride. Phosphorus oxychloride formation will take place, and in the same way acetic acid also react with SOCl2 to form CH3 COCl. In every case, you can see formation of acetyl chloride plus SO2 gas will be liberated plus HCl gas will be liberated. Next is it reacts with PCl3 to form same acyl chloride, CH3COCl, that acetyl chloride plus H3PO3, phosphoric acid will be formed. H3PO3 is phosphoric acid. Formation of phosphoric acid will takes place. This is reaction of acetic acid with PCl5, SOCl2 and PCl3. You should remember these reactions. Next is reaction with NH3. Your CH3COOH, that is acetic acid, react with NH3 to form ammonium acetate, CH3COO minus NH4 plus, this is ammonium acetate. If you heat this ammonium acetate, you will get acetamide, CH3CONH2 plus H2O. Means acetic acid on heating will form with NH3 will form acetamide. Acetamide formation will takes place. So these are some of the reactions. Next reaction is reduction reaction. Reduction reaction. Reduction reaction. If you take ethanoic acid CH3COOH on reduction in the presence of lithium aluminium hydride, this is a very good reducing agent, followed by acidic hydrolysis, H3O plus will give alcohol, CH3CH2OH. So reduction of acids with lithium aluminium hydride, or you can take any other reducing agents, followed by acidic hydrolysis will give alcohol. Here it is ethanol. Okay, and next is decarboxylation with soda lime. Decarboxylation with soda lime. Decarboxylation reaction with soda lime. See, you can take salt of acid, sodium salt of ethanoate or sodium ethanoate, CH3COO-Na, sodium salt of ethanoate. When you treat it with soda lime is a mixture of NaOH and CaO. On heating this, so this will be removed. It will form CH4 plus Na2CO3, sodium carbonate will be removed, that is CO2 will be removed from this, and this is called as decarboxylation. On reaction of this sodium ethanoate or sodium salt of carboxylic acid with soda lime will liberate carbon dioxide gas. Carbon dioxide will be removed. Okay, it will not liberate carbon dioxide gas. Carbon dioxide will be removed in different form, that is in the form of sodium carbonate. Next is one of the very important reaction of carboxylic acid, that is Hell-Vollard-Zielinski reaction. Hell-Vollard-Zielinski reaction. Here you will take acid CH2COOH. You can take any acid, carboxylic acid. This on reaction with halogen in the presence of red phosphorus followed by hydrolysis H2O will give alpha halo carboxylic acid. One of the very simple reaction. COOH. Alpha halo carboxylic acid can be prepared by the reaction of carboxylic acid with halogen in the presence of red phosphorus or followed by hydrolysis. Here X may be chlorine or bromine. Okay, X may be chlorine or bromine. So this is Hell-Vollard-Zielinski reaction. So you will get alpha halo carboxylic acid. You can add alpha hydrogen to you can add halogen to alpha carbon atom by treating it with halogen in the presence of red phosphorus followed by hydrolysis. Next is some of the last is electrophilic substitution reaction. Electrophilic substitution reaction. See, this benzoic acid acts as a meta-directing group. It is a meta-directing group. If you treat it with Br2 or FeBr3, that is halogenation of benzoic acid, will give meta-bromo-benzoic acid. Since I took bromine, I will get meta-bromo-benzoic acid. Meta-bromo-benzoic acid will be obtained. It acts as a meta-directing group. The nitration of benzoic acid. Nitration means you will treat it with concentrated HNO3 and concentrated H2SO4. This is a nitrating mixture. On treating benzoic acid with concentrated H2SO4 and concentrated HNO3, you will get meta-nitrobenzoic acid. Meta-nitrobenzoic acid will be obtained. On sulfonation, that is treatment with concentrated H2SO4, you will get meta-sulfobenzoic acid, COOH SO3. Meta-sulfobenzoic acid will be obtained. So this will not undergo Friedel-Crafts acylation or alkylation reaction because this is also acid. In Friedel-Crafts acylation reaction or reactions also you will use AlCl3, which is an acid. Acid-acid reaction will not take place. So this will not, they will not undergo Friedel-Crafts acylation and alkylation reaction. That completes this chapter. I tried to cover all the topics. If you have any doubts, you can ask me. Thank you.